welcome to my talk. I spend a lot of time on the CordaStack channel. I try to answer questions. Recently, I've been begging my teammates more and more often to actually do that for me. But during that time, I've seen a number of questions pop up and mistakes being made that happen more and more often than other questions. In this talk, I'm going to cover some of these mistakes I see happen very often. Let's figure out how to do this. So what will we cover today? So we'll start with what I think is the most common mistake Corda developers make, moving on to making sure that your CorDapp strictly enforce rules on transactions. Finally, how to prevent your flows from waiting for a call that never comes. So on to the first section, which is what I think is the most common mistake Corda developers make. Well, I hope so anyway. So does this stack trace look familiar to anyone? If it doesn't, then I've completely screwed this up. Personally, I've seen this stack trace way too many times, especially when I was starting out with Corda. Actually, in Corda 3, when I was starting out, it was actually much, much, much less helpful. It didn't tell you anything. I mean, really, what does that mean? Was expecting to find transactions set on current strand. I mean, that doesn't mean anything. Luckily, it's OK now. It kind of tells you what to do. An annotation is missing somewhere. The question is where to put this annotation. So the first common mistake is forgetting to add the suspendable annotation. To fix that error, all you have to do is remember to annotate any function that suspends with suspendable. But what does that mean? That's quite a big sentence to say, so let's break that down a little bit. Firstly, where does the suspendable annotation actually come from? And secondly, when does a flow suspend? The annotation, it comes from Quasar. Quasar is a library that we use inside of Corda to provide async functionality while allowing you to continue writing seemingly synchronous code. Quasar does some magic stuff to your functions. As much as I would like to tell you more than that, from your perspective as CorDapp developers, you don't actually need to know any more than that. I also don't actually have enough time to even talk about this. I had those slides already, but I cut them out ages ago. Corda does this under the hood. You just remember to add the annotation, and it works fine. All you have to remember is put the annotation onto the right functions. Let me and my team worry about this. More and more, it's being given to me, and really, you don't actually want to try and understand Quasar at all. So as long as you remember to put the annotation in the right place, you'll be OK. Next, when does a flow suspend? A flow suspends while it waits for a notification telling it to continue. All these actions on the screen are what can cause a flow to suspend. I expect most of you have only really used the first three, send, and receive, or you've definitely used a flow that does use one of these. So we now know when a flow suspends and where the annotation comes from. We can continue looking at how to fix the error we were looking at previously. So the next important thing we have to understand is that any function that calls another function that is annotated with suspendable also needs to be annotated. This is easier to explain with a simple example. So here we have run, which calls the action function. Action itself is annotated with suspendable. Therefore, you must annotate run. That's all you have to do here. So we can now have a look at a quick example. We now know enough how to fix this piece of code. So we have a function, we have call, which is delegating down to our receive function. Inside of that, there is the receive action. Remember, the receive action causes a flow to suspend. Therefore, receive must be annotated with suspendable. And also note that call has the annotation because it's calling the now suspendable receive function. So that's a simple example. Most of the time, you're not actually calling actions that directly suspend a flow. Instead, you're calling another flow that does this for you. And for the same reasons, you also have to remember to annotate those functions with suspendable, just like you would with the actions. So I think you've probably seen a number of these flows or used them as well. Probably the top four are ones you've definitely used. The last two, however, send and receive transaction flow, you've probably not used that much. They are, however, used by the rest of the platform flows quite thoroughly. More importantly, though, all of these flows suspend at some point. So any function that calls one of these flows must be annotated with suspendable. The same will also apply to any flows that you write. So if you call one of your own flows that can suspend, you must remember to put the annotation on that function. So here's a very slightly more complex example. We have two functions here at the bottom that call flows, collect signatures and finality flow. Remember, both of these flows suspend. So to fix this code, we need to add the suspendable annotation to those two functions. We also have to remember to annotate call because it is calling these other two functions, which are now suspendable. So on to the next section, which is properly enforcing rules on your transactions, more specifically, contract validation. To fully understand why we need contract validation, we should see what goes wrong if it's missing. So I've kind of stolen the IOU example that we used for our training. Here, Alice lends Bob some cash, along with an IOU stating how much he owes her. But Bob is a very sneaky person. He says he's paid off the IOU, but instead of paying the £1 million he owes, he's paid £1. Why could this happen? Because the contract looked like this. Literally anything could happen. At least Bob was kind enough to pay £1, right? I mean, he could have paid nothing if he really wanted to. What Bob did could have been prevented by adding the following code to the contract. It checks the amount of cash passed in is equal to or greater than the amount of the IOU. This is much better than leaving the contract empty, but there is still a lot of room for improvement. So we have our second common mistake, which is leaving your contract verification functions empty. Contract verification is very important to prevent the situation we have just looked at. It's there to prevent your states from being spent incorrectly. The importance of contract verification is highlighted by how useful it is. So a contract is tied to a state, and any time a transaction is validated, its rules will be run against the contents of that transaction. This means that no matter where a state is used, there are a set of rules that always hold and cannot break. So I've told you why you should try and include validation. The question is what to actually put inside of it. So first up, we have amounts and key fields. This is probably the most common one that you've included yourself. For example, you might want to check that the amount of money passed into a transaction is greater than 0, which is what this example is showing. Or maybe you have an enum field on one of your states, and only a certain set of its values are valid in the current context. Really, though, all I'm trying to say is that any important fields on your states contained in your transaction should be considered for validation. Checking the mixture or composition of states can be useful for some use cases. It ensures that any state that should be found with others is always found together. Or, on the other hand, if you have a state that should never be mixed with another state, it ensures that it's never there. Checking the relationships between states is kind of a progression from checking the composition of states. I actually find this one easiest to explain with my example. So I have two states, one input state representing an original message and an output representing the reply. So the rules check that the reply is sent from the original recipient of the original message and sent to the original sender. Finally, you should check the signers of your transactions. This is probably the one that is most likely to be missed, but it's probably also the most important. This ensures that any party that must sign a transaction will actually sign it. Leaving this out can leave you in situations where your states are being spent without you actually giving the all clear for that to happen. Okay, so I've blurred out this code. Your eyes haven't actually just gone completely crazy. I blurred this out to stop you from trying to actually read it. So this is code from the tokens SDK. And all I want from this slide is for you to appreciate how much work goes into writing a good contract. I mean, there's a ton of code, and there is a lot more in the tokens SDK, so trust me on that. Every point that we have just went over was included. They verified the mixture of states, they verified the amounts and the relationships between states, and finally, they verified the signers. So if you want a good example and inspiration on how to write a good contract, I would definitely recommend taking a look at the tokens SDK. So continuing with transaction validation, in this section, we'll take a look at why you should include validation in your responder flows instead of your contracts. So I'm going to use the same example as I did before, but this time we're going to assume that the contract has been fixed. So Alice has sent Bob some money. She also this time expects Bob to pay interest on the money she is lending him. So what does Bob do? Bob pays off the exact loan amount, doesn't pay any interest, because that's all the contract said he had to do. So he's paid $1 million, didn't pay any interest. So why could this happen? This could happen because there was no validation at the flow level to ensure that the interest was paid. Alice could have prevented this by adding the following check to her responder flow that checks that when she is sent the transaction to sign, she checks that the interest has been paid by Bob. So I thought while I was doing this, I would take a look at some of my own blog posts to see how I do this correctly. OK, so I left that one blank, so OK, there's one negative point to me. Another blog post, still did it wrong, OK, finally, I did something, but it was pretty useless. OK, so finally, I did something. I actually checked this. It took me 18 blog posts on Corda to finally actually start doing this right. That's why I'm preaching it to you, because even I'm doing it wrong myself. So we have the third common mistake, is leaving check transaction blank in your responder flows. This is for business level validation. This is completely different to contract validation. Contract validation checks that your states are being used correctly at a general level, not enforcing your rules. Business validation is checking are rules that are important to you, your business. What sort of values do you want to accept in transactions? Does this transaction actually contain information that's important to you? Or anything else that you and your organization thinks is important. It also prevents your node from accepting all transactions. So if you're missing this validation, anything sent to you that passes contract validation, you will just accept. If you're literally just taking it and signing it, you're not doing anything to it. So someone could send something to you that completely doesn't concern you. And you're just like, yep, fine, give it to me. I mean, you might be a big, mega evil corp and you're doing that anyway, but for most of you, probably not. So here's a quick example I put together. So the first point I want to highlight is contract verification is ran before we even get to the check transaction function. This means we can assume the transaction is valid. We can also assume the contents of the transaction based on the rules in the contract, which is why I'm able to assume there is a single message state here. Finally, you add whatever rules that you think are important. None of these rules would make sense inside of the contract because they are way, way, way too specific. None of these rules actually even make sense anyway because they're just some troll slide I put together. So what I've been talking about in the last few slides can actually be taken a step further to move CorDapps further away from purely shared code and closer towards applications that ensure your organization's needs are always met. So how do we do this? Well, we have flow overriding. Flow overriding was added in Quarter 4 and allows you to do what it says, override flows. So this allows you to add your validation for your specific needs to a shared CorDapp. So how do we implement this? In this big code block, we need to do the following. You need to have a base responder flow that is ready to be overridden. So that is send message responder right at the very top. Inside of this class, you need to have a function that should contain transaction validation that is ready to be implemented by any class that extends it. That transaction validation function should then be called inside of signTransactionFlow.checkTransaction inside of the base responder. When you create your overridden version, you then just need to extend the base implementation and implement the transaction validation function. This means now that any requests sent to the base responder will instead be routed to your implementation that contains your rules. Following this sort of pattern allows us to carry on using shared code, which is what CorDapps provide, while still ensuring that everyone's specific needs are met. Finally, we come to the last section, which is preventing your flows from waiting for a call that never comes. So the last common mistake that I'm covering here today, there are a lot more, is having unbalanced sends and receives. So every send must have a corresponding receive, period. If you don't, there's two different outcomes that occur. First case, and the worst case, in my opinion, is a flow stuck waiting forever. Now, I expect a number of you have probably seen these log lines before of a flow has been waiting so long to receive messages from parties. Again, like with the very first stack trace, I have seen this a lot. Best case, the flow fails instantly with an ended session error. I call this the best case because it fails straight away and gives you feedback, but it's still not that good. So here's a code example of a flow that is waiting forever. So both sides of the flow, the initiator and the responder, instantly call receive. And then after that, nothing happens. And then the waiting log lines start to pop up again. So to fix this, it's quite simple. We would just replace the first call to receive with a send, because it doesn't make any sense that they are waiting to receive straight away in the first place when they are initiating the messages between each other. This example is for a flow that fails due to an ended session error. So you have a first call to a send and receive. We have a first call of send and receive, which matches up to receive and send on the responding side. That responding side flow would then end after that final call to send. So when the second send and receive from the initiating side is made, it tries to contact the ended flow on the other side, which leads to the ended session error. So to fix this, we have two choices. We could remove the second call to send and receive, or we can add another pair of receive and send on the responding side, which would then mean that there's now a pair of send and receive and send between both sides, and then the flow would continue to work as normal. So those were kind of basic examples. Realistically, though, this can happen in flows. So this could happen when you are trying to sign and record a transaction where only a subset of parties need to sign that transaction. So any non-signing parties would end up waiting forever because they are missing a receive in the order of the code. All the signing parties, however, they work fine as all their calls sync up correctly. Unfortunately, I don't actually have time to cover this, even though this was actually the interesting part that would have been in this section. Fortunately, I have written a blog post on this already, so I have thoroughly explained it and given it the proper explanation it deserves in that blog post. I'd probably need about 15 more minutes to actually go through this, but we can't. So in summary, we have covered, you now know when to add the suspendable annotation. So you'll never see that annoying stack trace that you saw at the very start of the talk again. You now know why you should include validation and where to include it. So in both your contracts and your responder flows. And finally, you know to no longer have unbalanced send and receive, and you should always keep them in pairs. So what would be great after this is that for any of you that aren't already there, is come join the Corda Slack channel. If you do join, or if you're already there, if you could keep an eye out for questions that people ask, and maybe if I've actually told you something useful, you can tell them, you can answer some of their questions with the information I've just given you. Although I haven't actually seen that many questions on these recently, so it might not be that helpful. Finally, it would also be helpful if you do have questions, you could also put them on Stack Overflow. You could also nag tons of other people that are constantly asking questions in Slack to put their questions on Stack Overflow, but I'm not going to end on like an aggressive note. So thanks for coming to my talk on common CorDapp mistakes and how to fix them. So if you have any questions, be happy to answer.